In this podcast, we're going to talk about peptide bonds, how they're formed, and how to identify the N and C terminus. When we think about proteins, we're really thinking about a polymer of the monomer amino acids. So to make a long protein chain, we're going to have to take the monomers, those amino acids, and we're going to have to find a way to connect them and link them into a long chain of proteins. So these amino acids are held together by amide linkages, and in proteins, we consider those amide linkages to be peptide bonds. The bond is going to occur between the carboxyl portion of one amino acid and the amino group of another. So we're essentially taking a carboxylic acid and an amine group, and we're forming an amide bond. So we've already done this reaction before. We're simply forming an amide bond. The strung together amino acids, the now bonded amino acids, are going to have an N terminal, that's the side that has the open amino group, and a C terminal, which has the open carboxyl group. When we draw these, it's important to make sure that your amino is on the left and your C terminal is on the right for orientation purposes. All right, so let's take a look at what this looks like. So here we have the amino acid glycine, and the second amino acid is alanine. So as we talked about before, even amino acids can have an N terminal and a C terminal, but usually we reserve this for a longer chain of amino acids or a protein. So in our reaction, we know that our hydrogen from our N terminal is going to interact with our oxygen from our carboxylate terminal. We're also going to lose two hydrogens, and we're going to form the side product of water. So when we remove those, we're able to form an amide bond, and notice that there's no longer a charge on the carboxyl portion or the amino portion because now it's an amide. So we have an amide bond. When you're looking at a long chain of amino acids, if you can find the amide bonds, think of that as being the separation from one amino acid to another, because the reaction is going to be between the N terminal of one amino acid and your C terminal of another. So now we have, this is our amide linkage or a peptide bond, and now we have a dipeptide, meaning a two amino acid protein. So on this we have our N terminal, and that's our amino group, and we have our C terminal, and that is our carboxyl group. Notice that on your N terminal and your C terminal, we still have the zwitterionic form. So we still are showing that transfer of the proton from the carboxylic acid side to the amino side. But overall, the amino acid is going to be neutral still. All right, so if you have two amino acids that are joined together by a peptide bond, we would consider that to be a dipeptide. And I just pulled the amino acid that we were just looking at when we joined glycine and alanine. And again, if you were wanting to see where does one amino acid start and the other, or one stop and the other begin, you're going to look for that amide, and you're going to draw a line between the carbonyl and the nitrogen. So that's kind of the separating point because that was how we join those two amino acids together. We can name dipeptides, and we do that by taking the amino acid as an alkyl group, from the amino end. So this was glycine, and this was alanine. So we take the amino acid from the amine end and we name it as a alkyl group. So glycine would become glycyl, and then we just name the second one as is, alanine. So this dipeptide would be glycylalanine. This is not a really common thing that you'll see. You don't oftentimes look at just dipeptides. Normally you're looking at long sequences of proteins. And so when you're naming a long sequence of proteins, it can get awfully wordy awfully quick. So what you will see more often than that naming scheme is you will see the three-letter abbreviation for each amino acid being used. So this would be gly, ALA, ALA. Those are the three-letter abbreviations for those amino acids. Tripeptides are where you have 3 amino acids joined together by 2 peptide bonds. So we see in this, and again, if you're just curious where one amino acid stops and the other begins, look for that amide bond and draw a line between it. So here I have 1 amino acid, 2 amino acids, and my 3rd amino acid, and they are brought together by that amide linkage. We name these using 3-letter prefixes because, as I said, it gets very wordy. Once you start to get more than 3 amino acids joined together, we just call them all polypeptides. So there's many peptide bonds, there's many amino acids joined together. Our classification cutoff for amino acids and polypeptides becoming proteins is when we join at least 40 amino acids together. So if you get 40 amino acids together, that would be considered a protein at that point. So going back to the tripeptides, if this were threonine, we'd say THR, that's a 3-letter abbreviation. Second amino acid is leucine, LEU, and the final one is phenylalanine, which we just abbreviate PHE. And you can see phenylalanine has a phenyl group in it. So it's named aptly, and we can use some of our organic chemistry in looking at these amino acids.